Given are the two sets x and y which are both finite, and there is a function from x to y. Which of the following statement is true? See, for two sets x comma y, there is a function f from x to y. Now for any subsets a and b of x, f of a union b is equal to f of a mod plus f of b mod. This is also mod. Whether it is correct or not, let's see. Sorry, suppose a comma b is a subset of x. Given a and b are the subset of x, and s and t are the subset of y. Now let's draw an arbitrary function. I am drawing one function like this. This is set a, this is set b. 1 2 3 4 5, a b c d e, and a function from a to b. 1 is mapped to b. Let 2 is mapped to c, 3 to say a, 4 to say b, 5 to say d. Now first option saying that cardinality of, or you say mod of f of a union b is equal to mod of fa plus mod of function fb. Let's check whether it is true or not. Question mark. See, f of a, let's say decide this is set x and this is set y. Function is from x to y, so this is set x and this is set y. Now let's say that a is equal to 1 2 3 and b is equal to 4 comma 5. So a union b is f of 1 2 3 4 5. F of 1 2 3 4 5 is 1 is b, 2 is c, 3 is a, 4 is e, 5 is d. Mod is 5. Now on the other hand, fa is f1 2 3 is f1 2 3 cardinality plus fb is 4 5, f4 comma 5 cardinality. 1 2 3 goes to, sorry, let's f is equal to b is equal to 3 comma 4 comma 5. So f a is equal to f of 1 2 3, f b is equal to f of 3 4 5, f of a union b is 1 2 3 4 5. This is correct. F of 3 4 5 will be a, 4 to e, 5 to d, so that is a e d. Mod 1 to 3 is abc, abc. Mod of abc is 3, mod of aed is 3, and 3 plus 3 is 6, so they are not equal, hence option a is incorrect. Now let's check option b. They are not equal because it is 5, it is 6. Now we will checking option b. Option b says that f of a union b is equal to f of a, sorry, intersection f of b. This is also intersection, I have told wrongly. So let's check, let's see another function. I have taking a function set a, sorry, see, this is set x, 1 2 3 4 5. This is set y of a b c d e, function from x to y. Suppose 1 is mapped to a, 2 is mapped to b, 3 is mapped to again b, 4 is mapped to d, 5 is mapped to e. Now suppose that A is equal to 1 2 and B is equal to 3 4 5. Then f of A intersection B is A is 1 2 and B is 3 4 5. So f of A intersection B is 5 and f of 5 is nothing but null, that is again 5. Now f of A is AB intersection f of B. B is 3 4 5, that is 3 4 5. 3 is B, 4 is D, 5 is E, so that is B D E. Intersection of both the terms are B, but B is not equal to 5, so option B is wrong. Now we will check option C. Option C says that f of A intersection B mod is equal to minimum of FA comma FB mod. See, in the previous example, f of A union B, f of A intersection B is phi, so the cardinality of phi is 0. Now f of A, that is 1 comma 2, is AB. F of B, that is 3 4 5. 3 is B, 4 is D, 5 is E, that is, see, FA is 1 comma 2 cardinality mod, FB is 3 comma 4 comma 5, 3 4 5 cardinality. Minimum function is here, whole bracket. Now f of 1 2 is A comma B, cardinality 3 4 5 is B D E, cardinality minimum, this is 2 and this is 3, minimum of 2 and 3 is, result will be 2, but 2 is not equal to 0, so option C is also wrong. Now we will check option D, that is for any subset S comma T of Y, whether these are equal or not. Let's say that S is equal to, see, S and T are subset of Y and this is Y, so I am taking S is equal to A comma B comma C and T is equal to D comma E, this one and this one. Now since it is calculating inverse, so function needs to be 1 1 and on 2, and our function is satisfying both the conditions. So f s intersection T is equal to f inverse S intersection f inverse T. See, S intersection T is what? In our case it is, S intersection T is phi, whether equal or not. F inverse S, F inverse S, ABC, ABC is 1 2 3, intersection F inverse T, that is T is DE, D 4 5 and E 4. Now again the intersection of both the term is phi, and F inverse phi is nothing but phi, so phi is equal to phi, so option D is correct.